This is lesson 3-9, the Pythagorean Theorem. The Pythagorean Theorem is all based on triangles. It comes from Pythagoras, who was a Greek mathematician, and thus it was named after him. And so in the Pythagorean Theorem, since it's based off of a triangle, it's based off of a right triangle. So let's draw a right triangle up here very nicely. This is a right triangle. Let's move it up a bit. Here. I'll move my triangle over here. There we go. In this right triangle right here, the hypotenuse is the side opposite the right angle. In this particular triangle, the right angle would be right here, which means this side here is the hypotenuse, because it is opposite the right angle. The other two legs of the triangle are aptly named legs. This is a leg and this is a leg. Sometimes one is shorter than the other, sometimes they're the same length, so you can call one a shorter leg and one a longer leg, or you can just call them legs. The Pythagorean theorem describes the relationship between the lengths of the sides of a right triangle. Okay? And we'll get into more detail about what that is in just a minute or two. A conditional statement is an if-then statement. Your parents probably put quite a few conditional statements on you quite frequently. If you clean your room, then you may go to the movies. If you get a good grade in your report card, then you can have the keys to the car, whatever. A hypotenuse, or excuse me, a hypothesis is the part following the if in a conditional statement. If you clean your room, that's the hypothesis. Then, that's the conclusion, this will happen. So the part following the then is the conclusional statement. Okay, also called, okay. The converse is a statement that's obtained by reversing the if and the then parts of an if-then statement. We'll get into those in a bit more detail in a minute as well. Now let's take a look at it. The Pythagorean theorem says in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. It simply means if I take this side and I square it, and I add it to this side and I square it, it should equal this side when it is squared. Basically, this is what it means. If I have a right triangle, and I'll draw one here. If I have a right triangle, and we'll just do this one side is 3, this side is 4, and this side is 5. The Pythagorean theorem says the hypotenuse squared, which in this case is 5, is equal to the sum of the two legs squared, which would be 3 squared plus 4 squared. Well, 5 squared is 25, 3 squared is 9, and 4 squared is 16. 16 plus 9 does equal 25. So that's what the Pythagorean theorem says. In a right triangle, the sum of the squares of the two legs is equal to the square of the hypotenuse. That's what is being said. With that in mind, you can use the Pythagorean theorem to solve right triangle problems. As long as you have 2 out of the 3 pieces of the right triangle, you can solve a right triangle problem. Okay? We are going to solve and find the missing lengths here. Each one of these is a right triangle. The side opposite the hypotenuse is considered to be C. Even it could be labeled something different, so be careful. Sometimes they may label this E, F, and G, and so G might be opposite the hypotenuse, opposite the right angle, but G would still be the hypotenuse. If we look into this particular problem, the side opposite the right angle is right here. So here I have C squared equals 8 squared plus 15 squared. And it doesn't matter if it's 8 squared plus 15 squared or 15 squared plus 8 squared. C squared is going to equal 64 plus 225. There's 15 squared is 225. And then I'm going to add those together. 225 and 64 is 289. C squared equals 289. But I don't want to know what C squared is. I want to know what C is. So we must undo taking something and squaring it. So we need to take the square root of it, which is the lesson we did the day before. If you remember, that was the previous lesson, which was on finding square roots. So we take the square root of 289. That happens to be 17. So C is equal to 17, and in this case it was labeled in meters, so I should label it in meters. So C equals 17 meters. We found the length of the missing side. Now you won't always be looking for the hypotenuse. In this particular problem, in the second one over here, opposite the hypotenuse is 25. So if we were to set this problem up, if C squared equals A squared plus B squared, C in this case is 25, so we have 25 squared equals 7 squared plus B squared. 25 squared is 625, if you don't know that, stick it on your calculator. 7 squared is 49 plus B squared. We need to solve for B. In order to solve for B, we first have to get B squared all by itself. To do that, we'll subtract 49 from both sides of the equation. And 625 minus 49 is 576. And that equals B squared. Again, I do not want to know what B squared is. I want to know what B is. So I will take the square roots of both sides of this equation. And I will find that B happens to be the square root of 576, which is 24. In this case, it would be labeled in feet. So we can find any missing side by following the Pythagorean theorem. You just need to follow the steps. Now, sometimes we have word problems. It says, use the figure at the right. About how many miles is it from downtown to the harbor? Round your answer to the nearest tenth of a mile. Well, downtown is here. The harbor is here, so we're looking for this distance here. It's a right triangle, because here's our highway interchange up here. So we can find, by using the Pythagorean theorem, we can find what B is. Again, across from the right angle is the hypotenuse. So we would have 8 squared equals 4 squared plus B squared. 8 squared is 64, 4 squared is 16. So now I will subtract 16 from both sides of the equation. If I take 64 and subtract 16, I will get 48. Then I need to take the square root of both sides of this equation. There is no perfect square for 48. That's why it says to round to the nearest tenth. So if we take the square root of 48 and put it on our calculator, I get 6.928203, blah, blah, blah. Okay? But I need to round this to the nearest tenth of a mile. Here's the tenths position, so I'm going to look to the right. It is less than 5. So how far is it? B is equal to 6.9 miles. It's a word problem, so the distance is 6.9 miles. The next thing we're going to do with the Pythagorean theorem is we're going to talk about the conditional statements for a moment. An if-then statement, like if an animal is a poodle, then it is a dog, is called conditional. Every conditional statement has two parts, the if part and the then part. The converse of a conditional statement switches the if and the then parts. For example, if an animal is a dog, then it is a poodle. It switched. Our original one says if an animal is a poodle, then it is a dog. We switched the poodle part and the dog part. We switched them up to give us the converse. And if you look at the converse, if an animal is a dog, then it is a poodle, that is not true. If an animal is a poodle, then it is a dog, that is true. That if-then statement is true. However, the converse of that is not true. Okay? It is the converse of the first statement, but it is not true. Not every statement has a converse that is true. But the Pythagorean theorem, however, does have a converse that is true. The Pythagorean theorem, written as an if-then statement, says if a triangle is a right triangle with legs of length AB and hypotenuse C, then A squared plus B squared equals C squared. The converse of the Pythagorean theorem says if a triangle has side lengths of A, B, and C, and A squared plus B squared equals C squared, then the triangle is a right triangle with hypotenuse of C. You might be asking, what good does this do us? Well, now I can give you lengths and say, do these lengths make a right triangle? For example, you can use the converse of the Pythagorean theorem to determine whether a triangle is right or not. These are the given lengths, and we're going to determine if they make a right triangle. In problem 1, we have 5 inches, 5 inches, and 7 inches. All you need to know is which side is the hypotenuse. The other lengths, it doesn't matter which one is A and which one is B. The hypotenuse is always the longest leg because it's opposite the largest angle in a triangle. So this is my hypotenuse. 7 inches is my hypotenuse. So I'm going to see if 7 squared equals 5 squared plus 5 squared. 7 squared is 49. 5 squared is 25 plus 25. 49 does not equal 50, so this is not a right triangle. Funky looking 50. There we go. So this is not a right triangle. And let's look at our second problem. 10, 24, and 26. They're all in the same units. That's always something good to look at. Make sure they're all in meters or the one's not in centimeters. If I was to look at this, the longest side is 26, so 26 squared. Does that equal 10 squared plus 24 squared? If I stick 26 squared on my calculator, I get 676. 10 squared is 100. 24 squared is 576. And 676 does indeed equal 676, so this is a right triangle. So it is indeed a right triangle. So as you can clearly see, the Pythagorean theorem has many helpful uses. Of all the things that you do with triangles, this is probably the most frequently used and most helpful of all of the different things that you can do with triangles.